Right, and working on our last few problems for this section, I have a function, f of x is equal to x squared minus 3, and I'm going to find several things. I'm going to find f of a plus h first, then I'm going to subtract f of a. Once I've got those, I'm going to divide the whole thing by h. So let's find the pieces first of all, and then we're going to put it together as one big thing. Let's find first of all f of a plus h. Remember, whatever's sitting in here is going in for the variable. So the variable in this case is x, so I'm going to go a plus h. It tells me to square it and then subtract 3. Alright, or a plus h times a plus h minus 3. And working this, a times a is a squared. Outside is ah, inside is another ah, so 2ah plus h squared minus 3. And that looks like all we can do on that one. So let's go to the second part. The second part tells me I'm going to eventually need to find f of a. So f of a just says whatever's sitting in here is replacing the x on the right. So it's just going to be a squared minus 3. Okay, so take these two parts and let's actually answer. Okay, I know that f of a plus h, what that equals is everything I found right here. What f of a equals is what I found right here. So putting this together, we'll come down here with the equal sign, so I make sure I get plenty of room here. So it's going to equal a squared plus 2ah plus h squared minus 3. Okay, so there's that first part. Then minus f of a. There's a couple things here, so I'm going to put it in parentheses, but I'm about to put two terms behind a minus sign, so I want to make sure I subtract all of it. And then all divided by h. So let's just clean up the top, and that's about it. So a squared plus 2ah plus h squared minus 3 minus a squared plus 3 all over h. So a squared minus a squared minus 3 plus 3. 2ah plus h squared all over h. I am dividing by a single term, so I can write that as 2ah over h plus h squared over h. Those h's go away. The 1 down there cancels with 1 there. So my final answer is 2a plus h. And that's what all that simplifies to. So with this problem, the whole goal with this was just to show you how even in one problem we can practice plugging in two different things into our function and cleaning it up from there. If any of you guys go into the world of calculus, not sure if you're going to go to Business Math Part 2, this actual formula up here, this f of a plus h minus f of a, it's going to come haunt you here in Business Math 2. It all has to do with the foundations of a thing called a derivative. But if you're not going to Part 2, then don't worry about that. Let's go on to example 15, which is number 55 in the book. So grab your books again. Let's look on page 108 at number 55, and let's start right back up. And in this example, all we're doing is just practicing kind of understanding the notations and built kind of more towards real world. It says that f of t is going to represent the number of shares that Nancy owns in IBM. Okay? And then g of t is going to represent the price per share. So specifically, what we want to do is at time t. So the function f will tell you how many shares that Nancy owns at a specific time. And then g of t is a function that can help represent how much the price of each share is going to be at a specific time. So, you know, share prices change every single day, the whole stock market. And what it wants us to do is interpret this, how I interpreted f of t and g of t into a sentence, interpret the multiplication. So if we multiply the number of shares owned times the price per share, then what are we going to find? Well, the number of total shares times the price per share together is pretty much going to represent the total amount that she spent on the IBM shares. So the total, I guess we'll say total investment in IBM, we can write it just like that. Or think about it in terms of this. If you owned 5 t-shirts and they were each $10 a piece, then 5 times 10, what does that represent? The total amount of money you spent on those t-shirts, right? Well, if f of t represents how many shares she owns and g of t is the price per share, then that's the total investment or how much she spent on the IBM stocks. Okay, not too bad for a word problem. Let's go on to example 16, which is number 66. Well, in problem 66, basically what we're wanting to look at is the profit from selling pagers. And it tells us that we have a weekly fixed cost of $20,000. We have a variable cost represented by this V of X function. So we have two costs. We have a fixed cost and a variable cost. And then we have a revenue, money coming in, of R of X. And what does X represent? Well, X is going to be the number of pagers sold per week. So this back part right here in this parentheses basically tells me that they definitely don't sell anything less than 0, which makes sense. You can't sell less than 0 pagers, but that at most they can sell is 7,500 per week. And that might have to do with the fact that that's all they can at most produce per week is 7,500, well, according to all those work hours and everything. All right, so before we get started in this, the question is, what is the difference between a fixed cost and a variable cost? We have got two costs going on in here. One's fixed and one's variable. And notice the one that's variable has the function with it. Well, because fixed costs are things that you can always rely on. They're going to be there no matter what. Like, let's say the rent of the building. Your company has, always has to pay a fixed rent. That's something you can guarantee on. Or salaries. Those are always fixed costs. Specifically, it's going week by week. So those would be your fixed costs. Your variable costs are what change according to, let's say, according to the season. It could be your electricity bill, your water bill, depending on if it's hot, is it cold. Those would be variable cost. Other things you might consider is the cost of supplies. If gas increases, then obviously what it's going to cost a manufacturer to ship you your parts that you need is going to go up. So those would be variable costs. All right, now revenue, what revenue represents is the amount of money brought in to the company. So it's at the end of the week, it's all the money that comes in. So the difference between revenue and profit is the fact that profit is the money you get to pocket, it's in your account. So by the time you take the money that you brought in and subtract off what you had to spend to make that product, that's what your profit is. So here in part A, specifically, it wants you to write a function that represents the total cost. So I'm going to go C of X. I'm going to say C for cost. And cost has to be the sum of the two parts. It's got to be both the variable cost plus the fixed cost, which is $20,000. So if we write this out in an exact equation, it's going to be 0. And there were a lot of zeros in this one. I think 1, 2, 3, 4, 5, 1x cubed minus 0.01x squared plus 50x and then plus 20,000. And that right there represents the cost equation, because the full cost that this company has to accrue is part variable and part fixed. All right, now part B says it wants to know the profit. Like I said, the profit, we'll say P for profit, is the difference in the revenue and the cost. It's the money in minus the money out. Okay, so what this is going to be is our revenue function, which is negative 0.02x squared plus 150x minus all of what we just described in part A. I'm going to put that in a big parentheses, but I got to subtract all of that. So 0.000001x cubed minus 0.01x squared plus 50x plus 20,000. Okay, so I need to subtract all of that, all those four terms, from the first two terms in order to get profit. So if I help you guys out, let me go ahead and combine those for you. Okay, and the key with that is just making sure that this negative sign right here gets distributed to everything in there. So that makes that front term, that's negative with all those zeros in there, that 0.000x cubed term has to be negative, which I've got that in there. And then the negative 0.01x squared now becomes positive. And then the 50 becomes negative and the 20,000 becomes negative. Okay, so just had to watch out for that. And last but not least, just to finish this up, it says, what's the profit if 2,000 units are produced and sold each week? So C says, what's the profit when X equals 2,000? So just plugging that into our equation over here we just got for part B. And, plugging 2,000 in for the X cubed, then the X squared, then the X. And what I get is an overall profit, when I try this out myself, of $132,000. So this company, that's a lot. That's a good profit when you think about it. It must be a pretty big company. But if you can just sell 2,000 pagers, but then again, who uses pagers nowadays, right? It should be like cell phones instead. But if you sell 2,000 pagers, then this company is pocketing in their just themselves alone $132,000. Okay, so this kind of wraps up working with function notations. We're going to stop the video right here, and we're going to pick up and finish up chapter 2 in the next section.